In this video, I'm going to demonstrate how to use a switch to assist assembly synthesis for giving specification. On the left, a switch shows the specification. On entry, the register R2 is equal to some value in the memory, and on exit, R1 is set to 0 or 1 depending on the relationship between another memory location and the content of R3. When the user starts synthesis, in real time, a switch displays the information of each candidate generated shown in the middle panel. On top of the middle panel, a switch shows a score chart. The line in the score chart is the highest score we got so far doing synthesis. On the bottom left, a switch shows the candidate ranking. By default, a switch shows the top 5 candidates with highest scores. Those candidates are shown in ARM assembly, and the right column shows their corresponding instruction types. The user can always open the reference table to get the coarse-grained instruction types on the left and the fine-grained types on the right. On the bottom right, a switch shows the type frequency about the occurrence of each instruction aggregated for the whole program and for each instruction. For example, in this 3-instruction program, the general ref, logic, memop instructions have appeared, and the right column shows their average scores. In this situation, the user can click on those coarse-grained types to get the detail about fine-grained types information. If a candidate looks promising, the user can also click on it to inspect the execution trace and specification analysis to understand how this candidate violates the specification. On the right is the intervention panel. The user can assist the synthesis process by adding instruction-level constraints for the program, removing irrelevant machine state, and decomposing the specification into smaller problems. The user can annotate the assembly program to include or exclude instructions. A switch also automatically generates hints for your user using static analysis on the specification. In this situation, for example, the user would like to explore 2 ideas in parallel. For the first idea, the user selects the radio button for the first instruction and click Include. In the pop-up window, the user selects Load to indicate that load should be the first instruction of the program. And the user also marked Move as included for the whole program, which means Move should appear somewhere in the program. This kicks off a new synthesis instance running in parallel with the original synthesis instance. For the second idea, the user selects the original synthesis instance and apply a different intervention. The user marks Load as the first instruction and click Exclude to mark Move as excluded, which means Move should not be used anywhere in the program. This kicks off a third synthesis instance running in parallel. Currently, a switch is running with 3 synthesis instances. The alive updated score chart now shows multiple lines, each representing one of the parallel synthesis instances, labeled with the intervention that caused their creation. The user can also click on any point in the score chart and to redirect to that specific instance and check its progress. A switch highlights the selected instance with thicker lines in the score chart. The tree view also shows the relationship between these 3 synthesis instances. The node in the tree view and the breadcrumb is also clickable. The applied intervention table shows the intervention applied to this selected synthesis instance. In this situation, the user also noticed that some arbitrary registers appeared in the candidate but not in the specification, and they seem to be not relevant to the final code sequence. To guide a switch towards this idea, the user can remove all registers that do not appear in the specification except for some flag registers that might affect control flow. The user applied this intervention on top of the instance with Load and Move marked for inclusion, since it looks more promising in this situation. A switch proposed a default decomposition solution for users, and for example, if the user thinks it's reasonable, the user can directly apply this decomposition as a new intervention. If any instance succeeds, the task succeeds with a correct final program. The tree view will annotate the succeeded instance with a green node. and the user can also check the result via the final result button.